So this is the spectrum of DAB signal, and in this case the spectrum density again is tricky, because to see what is mainly the power received, you see in this case a very strange effect, but it is not strange, it is radiotechnical, it is physics. So let's change, for instance, the bandwidth. Now we read something, a marker in the range of 68 dB. Let's change the bandwidth. Oh, I have increased the bandwidth and the power looks to be increased, 64, 63. On the opposite side, I return back and I decrease the power and decrease the bandwidth. It go to 72. So what is the real measurement of the power received? I continue to increase the bandwidth and I continue to see the signal coming up in power. This doesn't mean that it is better. The carrier over noise typically stay the same, but you see an increase of the power because you make the sum of the total power like you have to do. Now I continue to increase the total bandwidth of the DAB signal is in the order of 1.5 megahertz. Now I am in 300 kilohertz of bandwidth, so I am not still taking all the power of the signal, but it is increased. It is in the range of 50 dB. Now I am at 1 megahertz and I have a value about 44, 45. Increase again, 2 megahertz. Now all the signal stays into the filter, but even if it is not a door filter, now the measurement is 43, 42, 43. Let's say 1 dB of uncertainty. I can, of course, being an OFDM, that it is a mix of modulation. You also see sometimes a blank coming into where it is possible for other transmitter to broadcast on the same frequency, SFN, single network frequency. Okay, but this is out of the scope. The scope is to demonstrate that for measuring the power of one signal, it depends from what signal is. You cannot use the same like a simple marker on a spectrum without changing dramatically the settings to get measurement that makes sense. You see that now selecting the bandwidth, I can get every measurement I want between 673 and 43. I think this is enough to understand that each kind of modulation needs a different way of measuring.